Okay, let's start looking at the definition of measures of center. Now, there's going to be three different cases that we're going to look at for measures of center. And those different cases depend on how big the data set that you're working with is. So we're going to start with probably, the simplest, smallest data set in order to introduce this idea of measures of center. But it gets it gets complicated when you've got, instead of having, 10 or 15 datums to work with, when you have hundreds or thousands or millions of datums. Okay, so I'm going to show you some techniques to deal with even the largest data sets. So let's begin here with definition of measures of center. And we're going to be looking at discrete datums and small sample sizes. So what do we mean by that? Well, discrete refers to a data type or a number type that is a countable number. So a countable number is something that you would count with your hands, right? So, you could count up to 5 with your hands, or you could count up to 7. All right. So this data set for random variable x is composed of all discrete datums. Okay, these are all countable numbers. All right. Now we're talking about also small sample size. So here what we've got is we have a sample size of 26. Now that's considered small. Now how do I define small? I define small as something that wouldn't take you too long to type into your calculator. So if it's small enough that you can type it into your calculator, 30 at most. I try to keep my examples when you have to use your calculator to around 12 or 15 at most. But doing 30 doesn't take too long, okay? So the reason why we're dealing with discrete and small sample size is to allow you to use your calculator and see how your calculator can be used to calculate these measures of center, okay? But when we get into larger sample sizes of hundreds or thousands, you're not going to want to type in hundreds or thousands of datums into your calculator to calculate measures of center. Okay, so there's going to be other methods to deal with that. Okay, so let's keep moving forward here. So just to let you know, this is, the kind of data that we're looking at, discrete data with small data sizes. All right, so first measure of center is called the mean. The mean is commonly referred to as an average. And the mean is a datum or calculated value within the range of the data set, which is an average of all datum magnitudes. So sample mean is going to be the sum of all the values of all the datums in the data set divided by the total count of datums in that data set. So here we kind of have it represented symbolically. So x subscript 1 or x1 is the first value in the data set. X2 is the second value in the data set. X3, X4, X5, all the way up to the 25th datum. That would be this one. And the 26th datum would be that one, the last one. So if we take all the datums in the data set from the first to the last, from the first to the last, and we add those up, and we divide it by the total count of the datums. So the total count we have is 26. So we divide that value by 26, we get 7. So 7 is the sample mean, or the mean of the data set. All right. Now let's look at median. So the median is a datum or a calculated value within the range of the data set such that 50% of datums are less than the median and 50% of the datums are greater than the median. So since we're dealing with a sample size of 26, the median will be a value where 13 values are lower and 13 values are higher than our median value, whatever that's going to be. So in this case, the median will be between the 13th and the 14th datum. So to calculate the sample median, we're going to take the 13th and add it to the 14th datum, and then divide that by 2. And so the 13th datum, if we count up above here, let's say we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the 13th datum is a 7. Then the 14th datum, which is the one that follows it, will also be a 7. And then we'll add those two together and divide by 2. And so our median is equal to 7. Okay, so this value of 7, what we would do is we'd kind of put a line right here, and this is our median. And so the median is a number where half of the datums are below it, so there were 13, and half of the datums are above it. All right. It just so happens that our median was calculated to be the same value as our mean here. Okay. But that's what the definition of the median means, is that 50% of the datums are less than the median and 50% of the datums are greater than the median. Okay, which is what I drew there up above. If there had been one less datum in our random variable, so if we had, instead of having a sample size of 26, we had a sample size of 25, which is an odd number, then the median would be exactly the 13th datum, because then there would have been 12 datums lower and 12 datums higher than that 13th datum. Okay. All right, so now let's move on to the mode. All right, so the mode is a datum or a calculated value within the range of the data set occurring with the greatest frequency. So here's, I've kind of restated our data set again of our random variable x. And so what value occurred with the highest frequency? Well, we can see that 4 had a frequency of 1, 5 occurred twice, 6 occurred 6 times, 7 occurred 8 times, 8 occurred 6, 9 occurred twice, and 10 occurred once. So the datum with the highest frequency is 7. So 7 occurs with the greatest frequency, okay, a frequency of 8. Therefore, the mode is 7. To help you remember that the abbreviation I'm using for mode is MO, is think of MO as most often, okay, the datum that occurs most often. So this method of determining the mode is exactly how calculators like the Texas Instruments and NumWorks and spreadsheet software calculate it, which is fine and good for comprehending the concept of the mode, but it's not sufficient when presented with continuous and large data sets. So that's kind of what I talked about at the beginning of this. Nature is random and complex, which does not always fit nicely into discrete, small sample sizes. So when nature is being studied, measurements are recorded, and these measurements are continuous with large or small sample sizes. So that's just kind of leading into the next thing I want to talk about. But for now, I just want to review. We have these three measures of center. Okay, we've got the mean, median, and the mode. And the mean is the average value of all of the datums in a data set. The median is the value within the range of the data set where half of the values are greater and half of the values are smaller. And the mode is the datum in the data set with the highest frequency. Okay, thank you. Let me know if you have any questions.